Hey y'all, so this is our video about points of discontinuity. So this is anywhere on the test or in the future that we ask you to identify where you have a hole or a vertical asymptote or jump discontinuity. So we have three types. Our first type is going to be infinite, second is removable, and third is jump. So y'all, with our infinite discontinuity is really just an asymptote. So that's going to be when I can draw a line that my graph is going to get closer to but never touches. I like to think of this as elbows, if you will, right? So anytime that I see something like this on my graph, that means that I have an infinite asymptote. Now the second type is removable. Removable is when we have a hole. We see this most with polynomial and rational functions. And y'all, on my graph, when I use my calculator, that doesn't show up. It's just going to look like a straight line. The last one I have is my piecewise function, or where we're going to see it on the piecewise function. Y'all, that's a jump, right? If I'm drawing my little man, and he's going to go down, 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 down. And when he gets here, he has to jump to get to the top. So that is a jump discontinuity. Now, when I'm solving these by hand, the first thing I need to do is factor my numerator and my denominator. So I see that I have an x squared minus 16 on top. I have two terms, and I can take the square root of both. So I'm going to use difference of two squares and factor this, x plus 4, x minus 4. I then need to factor my denominator. So I want to figure out what adds to negative 2 and multiplies to negative 8. So when I'm thinking about this, I'm going to guess 4 times 2 gives me 8. Positive 4 minus 2, that's on, it will add to negative 2 and multiply to negative 8. So we'll have x plus 4, x minus 2. Next thing I need to do is cancel out what's the same in my numerator and my denominator. So I see this factor set of x plus 4 in the top and bottom, so I'm going to cross those out. At this point, I don't need my numerator anymore. It's given me all the information. What I removed is going to be my removable discontinuity, or my hole, and what's left is my vertical asymptote. Y'all, a lot of us got to this point, but we did not finish. So here's how we finish this. We need to set each factor set equal to 0 and solve. So when I'm thinking about my removable, I have x plus 4 equals to 0. So I'll subtract 0 from subtract 4 from both sides. And we have x equals negative 4. On the right side, I'm going to add 2 to both sides. And I see that x equals 2. So I will have a vertical asymptote at x equals 2 and a removable discontinuity where x equals negative 4. Y'all, if you have any questions about solving this by hand, pause and call me or Miss Gladney over. The next way we're going to see this, y'all, is when we solve using our calculator. So when I solve on my calculator, the first thing I'm going to do is graph it. So I'm going to graph whatever my equation is, and I'm going to see what it looks like here. So I notice a few things right off the bat, right? I see these elbows here. That indicates to me that I'm going to have some sort of discontinuity because the two sides of my graph are never going to touch. So those are just things that I notice right off the bat. The next thing I need to do is I need to find my table. So I'm going to press Control T, and then my table will come up. I am looking for anywhere that my graph says hashtag undef, or sometimes it'll say indef. Y'all, a lot of us got to this point and then we didn't label which one is which. So when I'm looking at negative 3, 2, and 4, I identified those are the three places where I have an undefined value. So I'm going to say x equals negative 3, x equals 2, and x equals 4. If that is the case, I now need to go look back at my graph and figure out what type of discontinuity I have in each of these places. So let's go back to my elbows, right? I saw one right here. That's going to be at -1, -2, -3. So this is going to be one of my vertical asymptotes. The next thing I see is that we have one where I have one here, excuse me. So that's 1, 2, that's where x equals 2. That is also going to be a vertical asymptote. So now I have this where x equals 4. I got 1, 2, 3, 4. Y'all, when I look here, it's just my plain old line. What that tells me is that that's my removable discontinuity or my hole. If you have any questions about any of that, y'all, please feel free to rewind and rewatch it or call anyone over. Y'all are rock stars.